Welcome to 7th grade math. That was your homework that was due today. Mini lab. Use centimeter cubes to make the three figures shown. How many centimeter cubes are used to make each figure? Figure 1, there are 4. We know that just by counting them. Figure 2, there are 8. There's 2 rows of 4. And then figure 3, there are 12. There are 3 rows of 4. What pattern do you see? Describe it in words. Each time, 4 more cubes are added. Support this pattern continues. Complete the table to find the number of cubes needed to make each figure. So that table shows figure 1 has 4, figure 2 has 8, figure 3 has 12. So how many will figure 4 have? 16. And figure 5? 20. So how are you calculating that? Well, there's two ways you could, right? I could look at next one is 6, so I could add 4. Or I could say, okay, 7 times 4 is 28. So then 8 has 32. 9 times 4 is 36. And 10 times 4 is 40. Because number 4 below wanted us to show how many cubes are in the 10th figure. Let's look at another pattern. So we have figure 1 has 3 blocks. Figure 2 has 5 blocks. And figure 3 has 7 blocks. What pattern do you see? Describe it in words. Each figure increases by 2 blocks. Suppose the pattern continues. How many blocks would there be in figure 5? Well, figure 4 has 9 blocks, and figure 5 would have 2 more than that, so 11 blocks. Sequence. An ordered list of numbers. Term. Each number in a sequence. An arithmetic term. Each term is found by adding the same numbers to the previous term. So let's look at an arithmetic term. We have 8 plus 3 is 11, plus 3 is 14, plus 3 is 17, plus 3 is 20, plus 3 is 23. Each term is found by adding 3 to the previous term. So we'll look more at that coming right up. Example, describe and extend sequences. Number 1, describe the relationship between terms in the arithmetic sequence 8, 13, 18, 23. Write the next 3 terms. So first we have to discuss what is the difference. How do we get from 8 to 13? Well, if we find a difference, it's 5. So 8 plus 5 is 13. Does that pattern continue from 13 to 18? Yes. 13 plus 5 is 18, and 18 plus 5 is 23. So 23 plus 5 is 28, and 28 plus 5 is 33. So those are the next 2 terms, and then we'll find the third, which is 33 plus 5 is 38. Check your progress. So describe the relationship in terms in an arithmetic sequence. Write the next 3 terms. So A is 0, 13, 26, and 39. So how do we get from 0 to 13? We're going to add 13. And then we're going to add 13 to get from from 13 to 26. Plus 13 is 39. And now we need to add 13 to 39. We get 52. Add 13 to 52. We get 65. And add 13 to 65. We get 78. So B, we have 4, 7, 10, 13, and we go from 4 to 7 by adding 3. 7 plus 3 is 10. 10 plus 3 is 13. 13 plus 3 is 16. 16 plus 3 is 19. And 19 plus 3 is 22. Scaffolding questions. Describe and extend sequences. Describe the relationship between terms in each arithmetic sequence. Then write the next 3 terms. So we have 10, 12, 14, 16. 10 plus 2 is 12. 12 plus 2 is 14. 14 plus 2 is 16. Then we add 2 to 16, we get 18. 18 plus 2 equals 20. And 20 plus 2 equals 22. So for number 2, we have 25, 30, 35, 40. Difference between 25 and 30 is 5. 25 plus 5 is 30. 30 plus 5 is 35. 35 plus 5 is 40. 40 plus 5 is 45. 45 plus 5 is 50. 50 plus 5 is 55. Number 3, we have 0, 3, 6, and 9. 0 to 3, we add 3. We add 3 to 3 to get 6. Add 3 to 6 to get 9. 9 plus 3 is 12. 12 plus 3 is 15. And 15 plus 3 is 18. How did you find the next number in each sequence? By adding the difference between consecutive numbers to the last number. Example, describe and extend sequences. Describe the relationship between terms in arithmetic sequence 0.4, 0.6, 0.8, 1.0. Then write the next 3 terms. So we have 0.4 plus 0.2 equals 0.6. So here's an important thing. Don't let the decimal make this more confusing than it needs to be. If you want to say this out first, you could say, just to find a pattern, instead of 4/10, 6/10, 8, you could just say 4, 6, 8, 10. We know that the pattern is we're going to add 2, but in this case there is a decimal, so we're going to add 0.2. So plus 0.6 plus 0.2 is 0.8, plus 0.2 is 1.0, plus 0.2 is 1.2, plus 0.2 is 1.4, plus 0.2 is 1.6. So check your progress. We have 1.0, 1.3, 1.6, 1.9. 1.0 to 1.3 is 0.3, plus 0.3, plus 0.3. So then we have 1.9 plus 0.3 is 2.2, plus 0.3 is 2.5, plus 0.3 is 2.8. And for D, we have 2.5, 3.0, 3.5, 4.0. This is very similar to another example we just did where it was whole numbers. It was 25, 30, 35, 40. This is going to be the same pattern, except instead of whole numbers, we're going to be dealing with decimals and 0.5. So 2.5 to 3.0 is 0.5, plus 0.5 is 3.5, plus 0.5 is 4.0, plus 0.5 is 4.5, plus 0.5 is 5.0, and plus 0.5 is 5.5. In a sequence, each term has a specific position within the sequence. Consider the sequence 2, 4, 6, 8, 10. 2, 4, 6, 8, and 10. 2 is in the first position. 4 is in the second position. 6 is in the third position. 8 is in the fourth position. 10 is in the fifth position. The table below shows the position of each term in this sequence. Notice that as the position number n increases by 1, the value of the term increases by 2. So if it's in position 1, and we increase one position from 1 to 2, we're going to increase the value of the term from 2 to 4, so that is plus 2. So 2 to 3 is 1, 4 to 6 is 2. 3 to 4 is 1, 6 to 8 is 2, and 4 to 5 is 1, and 8 to 10 is 2. So if we do the math out, it's 1 times 2 equals 2, 2 times 2 equals 4, 3 times 2 equals 6, 4 times 2 equals 8, and 5 times 2 equals 10. You can also write an algebraic expression to represent the relationship between any term in a sequence and its position in the sequence. So in this case, if n represents the position in the sequence, the value of the operation is going to be 2n. So 2n is 2 times 1 in the first one, 2 times 2, 2 times 3, 2 times 4, and 2 times 5. Real world example, greeting cards. The homemade greeting cards that Meredith makes are sold in boxes at a local gift store. Each week the store sells 5 more boxes. So if you look at the stacks, week 1 has 1 stack of 5, week 2 has 2 stacks of 5, and week 3 has 3 stacks of 5. If this pattern continues, what algebraic expression can be used to help her find the total number of boxes sold at the end of the 100th week? Use the expression to find the total. So here's the position and the value of the terms, because we know that week 1 is 5, week 2 is 10, week 3 is 15, week 4 is 20, and then we're going to write an expression for n and the value being 5n. Plus 1, plus 5, plus 1 in position, plus 5 in value, plus 1 in position, plus 5 in value. So if we do 1 times 5 equals 5, 2 times 5 equals 10, 3 times 5 equals 15, 4 times 5 equals 20, and then we have n times 5, which we rewrote in the value as 5n. So 5 times 1, if we write it that way, 5 times 2, 5 times 3, 5 times 4, 5 times n. And then with that 5 times n, we can find the value of any position in the sequence. If we do the 10th position, 5 times 10 is 50. So if we look at the value for the 10th position, the 100th, 5 times 100 equals 500. So at the end of 100 weeks, 500 boxes will have been sold. Check your progress. Geometry. If the pattern of circles continues, what algebraic expression can be used to find the number of circles used in the 50th figure? How many circles will be in the 50th figure? So if we use our table again, position 1, position 2 is 1, but the value is plus 3. So we have plus 1, plus 3, plus 1, plus 3. 1 times 3 equals 3. 2 times 3 equals 6. 3 times 3 equals 9. 4 times 3 equals 12. And then we have n times 3. So if we restate that as 3n, then we have 3 times 1, 3 times 2, 3 times 3, 3 times 4, and 3n. Each term is 3 times its position number, so the expression is 3n. So if we write the expression and then we plug in 50, so we can find how many circles will be in the 50th position. 3 times 50 equals 150. Replace n with 50, which we did. So the 50th figure will have 150 circles in it. Additional examples, describe and extend sequences. So if we have, for number one, if we have 7, 11, 15, and 19, we know that 7 plus 4 equals 11. 11 plus 4 equals 15. 15 plus 4 equals 19. 19 plus 4 equals 23. 23 plus 4 equals 27. And 27 plus 4 equals 31. For number two, if we have 0.1, 0.5, 0.9, and 1.3, we know that 0.1 plus 0.4 equals 0.5, plus 0.4 equals 0.9, plus 0.4 equals 1.3, 1.3 plus 0.4 equals 1.7, plus 0.4 equals 2.1, plus 0.4 equals 2.5. Mamet started a new exercise routine. The first day he did 2 sit-ups. Each day after that he did 2 more sit-ups than the previous day. If he continues this pattern, what algebraic expression can be used to help find the total number of sit-ups on the 10th day? Use the expression to find the number. So here's our trusty little table. And if we look at the difference between positions, it's +1. And every time we go up 1 in position, we're going to go up 2 in the value of the term. So we can see that's true throughout our table. So our operation is going to be 1 times 2 equals 2. 2 times 2 equals 4. 3 times 2 equals 6. 4 times 2 equals 8. And we can make that an expression. If position is D for days, operation would be 2D, which means increase the number of sit-ups by 2 every day. And then we can write an expression of n times 2, or 2D. 2 times 1, if we plug 1 in for days. 2 times 2, 2 times 3, 2 times 4. So if we look at 2 days and we want to see how many sit-ups he did on day 10, 2 times 10 plugged in for D is 20. So he did 20 sit-ups on the 10th day. All right, here's your homework. Go ahead over to Google Classroom and enter it there, please. Thank you very much.